The next thing that we have, I don't think any of this was anything particularly new. Maybe the masses were new to you. But what we're going to talk about now is thinking again about how all of these little particles here that make up an atom, how can they make up different elements? Okay, so we've got elements, which is what all matter is made up of. And we've got all kinds of different elements. We've got things like carbon, we have oxygen, we have hydrogen, we have mercury, gold, silver, tin, lead, arsenic. We've got all kinds of different elements. So if all elements are made up of atoms, and all atoms have protons, neutrons, and electrons, how can one element be different from another? And the way that one element is different from another is in the number of protons. The number of protons is what decides the element that you're looking at. Like lithium, for example, you find lithium in different batteries. Lithium has 3 protons. You look at hydrogen. Hydrogen has only 1 proton. Helium has 2. Carbon has 6. Oxygen has 8. Sulfur has 16. So as you change the number of protons, you end up with a different atom. Sorry, not a different atom. You end up with a different element. So the thing to keep in mind here, if we change the number of pluses, and if we know that an atom has to be neutral in its overall charge, we have to change the number of electrons. There has to be an equal number of protons and electrons. So, anyways, we'll move on to that part a little bit later. What we have right here is something that we call the atomic number. And this relates because the atomic number is what tells us the number of protons that are found in the nucleus of an atom. And that's very important because we know that the number of protons tells us what element we're looking at. So the atomic number is super important because it decides the element that an atom is. So let's zoom in on that puppy. Too much in. The number of protons in the nucleus of an atom is the atomic number. Please keep in mind you have got the power to press pause. Okay. The good news for you guys is that we are now at the last definition to record for our notes today. We talked about how the atomic number is what decides what element we are looking at. So what we also need to keep in mind is that if we change the atomic number, that is, we change the number of protons, we also have to change the number of electrons. Because an atom has to be neutral. It has to have as many pluses as it does minuses. So, we change the proton number. It means we end up changing what element we're talking about. We change, and the electron number changes at the same time. However, it is possible for elements or atoms of one particular element to have different numbers of neutrons. Now when this happens, we have something that we call an isotope. And all that an isotope is simply an atom with the same number of protons. Keep in mind, number of protons indicates what element we're talking about. So if it's got the same number of protons, it means we're talking about the same element. But it has a different number of neutrons. So the only thing different between like an isotope of carbon might be, yes, they both have 6 protons and 6 electrons, but they've got different numbers of carbon atoms. So let's just zoom in on that. You can always press pause. So hopefully what you see from all of this is that something very, very small such as the protons and the neutrons and the electrons. The number of them can make a huge difference on what substance something is. That's what decides what substance a given object is the number of protons, neutrons, and electrons found in the atoms. So, what you guys need to do now, make sure that you save your notes. You might want to save them to a special science folder on your computer. After that, read the instructions for how to do your homework, and if you finish your homework early, then check out the Atom Builder simulation. It's on the More Information page. It's pretty neat, and hopefully you'll get a little bit more familiar with how protons, neutrons, and electrons work together to create atoms. So, have a good day. Bye.